Hi guys, and welcome to another HSC Chemistry video. This one on the acidic environment is on titration procedures. So we're going to have a little bit of a look at titration in a little bit more detail, specifically relating to the equipment that is part and parcel of a good titration procedure. To do that, we look at three things. We need to look at the pipette, particularly the bulb pipette. We just go to a blue here, the bulb pipette. We need to look at the burette, and we also need to look at the conical flask. And this is particularly in terms of care, but also in terms of how you wash and prepare each of these pieces of equipment prior to their use. So let's have a look firstly at the pipette. So this is a bulb pipette. You can see in this region, it tells you what the volume, which is 25 mils. You can also see at the top here, which is the graduation mark. And that graduation mark is the one that we need to fill to in order to make sure that we get exactly 25 mils. Now, when we're doing that, we need to make sure that the bottom of the meniscus sits directly on there. So it needs to be slightly curved so that the bottom of that meniscus is sitting right on that graduation mark. And of course, you're going to make sure that you can only see the line. You don't want to see the full circle. If you can see the full circle, you're not looking directly at it and you're going to make an error. The engraved line is what helps us to ensure that we have a precise volume. And of course, the pipettes come in different sizes, 10 mils and 25 mils and 50 mils and so on. Most of the ones that you guys have seen have been the 25 mil ones or the 10 mil graduated pipettes with all the little scales up and down the sides. Now, when we're going to use the pipette, and this will have a bulb which is sort of sitting up here somewhere, the rest of the equipment with the little on the top. And three steps basically. One to squeeze the bulb, the second one here to draw the liquid up into the pipette, and the third one to release the liquid. And then we can just, once most of the liquid's out, we can just press that little bulb and also just touch the pipette onto the side of the flask in order to make sure that the last of the liquid actually exits the pipette. But prior to doing that, you need to make sure that you prepare your pipette. So you'll need to rinse the pipette. You should always start with a clean, dry piece of equipment. But if we rinse the pipette several times with distilled water, that of course should be distilled water. And then what we need to do is rinse with the solution to be placed in the pipette. So we need to actually use the solution that's going in the pipette. So if it's an acid, we need to rinse the pipette with that acid. Because we're looking for a specific volume, that specific volume of a specific concentration will have a specific number of moles. So we don't want to change that concentration by having distilled water, for example, still sitting in the side of the pipette and just slightly reducing the volume that we will collect. Some of that will still be the water. So we need to make sure that everything that's in there is actually the solution. Now, there's also a term that you may read which refers to the liquid in the pipette that you're going to transfer to your reaction flask, and that's called an aliquot. So you may sometimes see references to several aliquots were used in the carrying out of a titration, and that's what that term refers to. So as far as the pipette's concerned, the main thing we need to do is to remember to wash the pipette with the solution that's going into it. The second piece of equipment that's really important is the burette. Now, this is a burette over here. You can kind of see the scale on it. It's not particularly good. And also the individual graduations going down to 0.1 of a mil. And in fact, you can probably read to 0.05 if you can sort of get halfway in between those. So it's a very accurate technique. And because of that, we need to be very careful that we're using this correctly. As a consequence, again, it should be clean and dry. We shouldn't store them with liquid in them. We should make sure that they're cleaned and dry. We rinse them with distilled water, just in case there's anything left in there from previous titrations. But then again, as with the pipette, we want to use the solution which will be placed in there. So we have to make sure that, again, with the burette, we fill the burette, or at least partly fill the burette. We allow some of that liquid to run through the tap. So we open the tap, the section down here, which is where the tap is, so that the liquid will run all the way down and out. And then we also can invert the burette and just roll it and allow it to pour down the sink. So if you slowly turn the edge of the burette as you're doing this, then the liquid will run all the way around the edges of the burette and make sure that it completely coats it in the solution that you're going to put in there. When you're filling the burette, you use a small funnel. Usually that will be a glass funnel. Don't use one of the large filter funnels that you would normally use for filtration, because it's too big and the weight can tip the burette. You will be holding the burette in a burette clamp, which will be attached to a retort stand. You might see one of those. You can probably see one in the background, actually. Although that looks more like an incorrect piece of equipment, so we can spot the mistakes here. But usually this will be a little glass funnel, and make sure you take the funnel out once you've finished using it. So you fill the burette and then remove the funnel until you're going to be adding more solution to the burette. We don't leave the funnel in the burette when it's not in use, because it's just good practice, and it's also a safety measure. But you may use a paper clip on the edge of the funnel just to break the air seal. So it just makes it easier to fill, and you don't end up with the liquid pouring back out of the funnel. Using a waste beaker is pretty important, because if you put the waste beaker underneath the burette when you're running out excess liquid, you can keep that to one side and make sure that any excess, the same thing with the pipette, you don't want to be turning the pipette upside down and contaminating the bulbs. But what you do want to do is, if you slightly overshoot, you want to make sure that you run some of that liquid from the pipette as you're getting it back down to the graduation mark, and the burette as well should be drawn down to the 0 mark, so that the bottom of the meniscus sits on the 0. And any excess, so if you overshoot, then you can always bring that back down and put that into your waste basket, waste picker. Now, we use the term aliquot to describe the volume that was in the pipette. For the burette, we call it a titrant. So there are a couple of additional terms associated with this technique. And the third piece of equipment that we need to look at is the conical flask. And this one is slightly out of focus by the looks of it, but it is a conical flask nonetheless. This is also called an Erlenmeyer flask, and the key is this is our reaction vessel. This is where the reaction takes place, the neutralization reaction, or any other reaction. We are just using titration for neutralization reactions, but there are other types of reactions that use this technique as well. As far as a conical flask is concerned, again, it should be clean, it should be dry, but we only need to rinse it with distilled water. This time we don't actually want the solution in here. Because we're going to be transferring a known amount into our flask, we want to make sure that we don't, if the whole of the flask has been washed in that same solution, then you're going to have more of that solution in there than you're originally planning. So water's okay, it's not going to affect the number of moles of our acid or base, and so it's fine for the flask, but no rinsing with the solution. And of course, don't forget the indicator. When you have transferred your aliquot of solution into your flask, it's very important that you make sure you add your drops of your relevant indicator. Particularly if you're using phenolphthalein and you're starting with an acid, looking for it to turn pink, it's going to remain colorless. And if you don't put the indicator in, it's just going to continue to remain colorless until you've way overshot your mark. So always add a couple of drops if you think you've gone too far, just to test that you have. A couple of drops are not going to significantly affect your results, but if you've overshot the mark, you'll see that pink color comes straight away, and you'll know that something is wrong. Because we're trying to find some very subtle color changes, it's useful to make sure that you have a white tile or a card sitting underneath your flask so that the color is very easy to see. You can see this tile here is a little bit dark and discolored, and so it can sometimes make any slight colouring that we see in the flask a little more difficult to pick up. In 2013, there was a 5-mark question on good techniques. It was question 28, and I'm actually going to start with the questions and then work through each of these as we get to them. So the method you're going to see describes a procedure for carrying out a titration. And we're told that in steps 2, 3, and 4, the student did not follow acceptable procedures. We need to identify the mistake in step 4. So keep an eye out for a mistake in step 4 and a change, and also the effect of the mistakes made in steps 2 and 3. So how about we analyze each one of these in turn. So here's the first part, 5-mark question. Student attempted to determine the concentration of hydrochloric acid solution. Perform some steps. The conical flask was rinsed with water. Well, we're assuming that that's distilled water, but assuming it is, he gets a tick for washing it with distilled water. 25 ml pipette was rinsed with water. Okay, no tick for that one. The problem is that if you rinse your pipette with water, then you're going to dilute your solution. And if you dilute the solution, then what you end up with is a lower concentration. Lower concentration. And that is going to affect the calculation that you perform at the end of the process. In step 3, the student filled the pipette with a standard sodium carbonate solution to the level shown. Now you can see here's the graduation mark, and the level is actually sitting below. Okay, where the meniscus is, it's actually sitting below the graduation mark, and it should actually be up here. So that also means that that we're not actually measuring from 0, so that the volume, the final volume, okay, which may read 23.3, may actually be closer to 23.2. That doesn't seem to make a lot of difference, but those of you who have already started to do some calculations know that these little errors can certainly affect your final calculations. So this is one of the reasons why this is another error here, and we need to make sure that that meniscus sits directly on that graduation mark. For both of these, the problem that we have is that when you are carrying out the titration, you're going to change the amount of moles that you have of the solution, which in this case is the sodium carbonate solution. So if we then compound that mistake, then what we're going to do is we're going to end up with a different amount of hydrochloric acid required. So because that volume is going to be slightly less, then the calculation is going to appear that the number of moles that is required divided by a volume that's slightly less is going to increase the overall answer, and so you're going to end up with a value that's quite a little bit higher than what we would actually expect. In step 4, standard sodium carbonate solution in the pipette was transferred to the conical flask. That's all right. The student ensured that all of the sodium carbonate was transferred to the conical flask by blowing through the pipette. Well, hopefully you'll see a word like that and go, oh dear, that's not a good technique. If we've got a bulb, then we just press the little the extra little section on that pipette bulb. Alternatively, what we can do is touch the edge of the pipette onto the side of the flask and just allow the natural cohesion, surface tension of the water to actually pull the last of the water or the last of the solution out of the pipette. Okay. So blowing is a problem. We don't want to be emptying our pipettes by putting our mouth anywhere near any of this equipment. So that's a big mistake. And as I said, if you just touch the end of the pipette to the surface of the flask, the edge of the flask, that will draw out the remainder of the liquid. 3 drops of an appropriate indicator were added. 3 drops is okay, so no problem with that step. And then in step 5, burette was rinsed with hydrochloric acid solution, which it should be, and filled with the acid. That's the solution that's going in it, that's filling it, which is fine. Student carried out a titration to determine the concentration. So this is the method of the student. So they identify the mistake that the student made in step 4 was the blowing. That was the problem that we had here. We don't want to be blowing. And the effect of the mistakes 2 and 3 on the calculation. So the first one was the lack of rinsing. And so that will change the number of moles, and then the final one was the graduation mark, which was lower, so therefore we would have a lower volume, and when we do our calculations that's going to lead to a higher concentration. Thanks for watching.